Okay, so we've created a few measurements on this block of wood, but I want to move back to the scan screen and talk a bit about exposure. Exposure is vital to getting good measurements. So I used the default setting for this block of wood, which was fine, but I'm going to take this block of wood out and replace it with a couple of targets, a white tube and a black rubber stopper. And I've chosen white and black because that's kind of the extreme in terms of contrast. And we're going to look at those with one scan. And the first thing I'm going to do is go right into the video mode and kind of show you with the current default setting what this video looks like. In the video mode, there's the ability to use this exposure map. And what this does is it color codes based on certain levels of light. So the blue represents areas where we have no light essentially. We're below our threshold. And the red represents areas where we're saturated, where the pixels are saturated. We don't want, there's going to be a lot of blue on here because there's a lot of areas where we don't measure light, but when we're looking at the target, we should have some form of grayscale. And we don't want too much red because it means we're saturated. And that's a problem sometimes when we want to calculate center of gravities accurately in terms of getting our profile map. So what we can see here from the white and the black is that the white is obviously reflecting a lot more light, so we have kind of some saturated pixels here. And on the black, it's much more faint. If we look back at the actual image, we can sort of see some of the light there. And that's to be expected between black and white. Now, if I look back at the profile, we can see that we're still, even though we're saturated on the white, we're still getting a fairly good profile, and that's fine. It's probably not optimized, but it's still pretty good. But if we look at the black, we're missing some points here, and that's just because we just don't have enough light. And the way we add more is essentially have a larger exposure. I'm going to take this 400 and double it to about 800, and now we can see that we're getting pretty good profile on the black. Again, we're probably not optimized on the black and the white, but in this case, we're able to measure both the black target and the white target with the same exposure. And this is something related to this technology that really kind of shows that it's much more forgiving of target colors and reflectivities. If I can measure black and white with the same exposure, then I can naturally measure all the other colors in between. Things like yellow and purple and green and red would be just fine, or various shades of gray. So it's quite forgiving. Now, I'm probably not optimized on this, so if I wanted to, I could actually use a different style of exposure. So I can select not just a single exposure, but I'm going to click over to this multiple exposure. This is actually a way to optimize and do multiple exposures at different levels, kind of like an HDR that you might have with a camera. So I'm going to select multiple. And for this first exposure, I'm going to select something very low. And we'll go into the video mode. I'm selecting 100 microseconds. And you can see that if I go into this video mode and look at my exposure, that this is actually right about the level of light I want. I want to cross a good amount of pixels, not have any saturation, and that's just fine. So we're going to use that exposure, and we get this profile. Now you see we don't see the black at all. It's because the exposure is too low. But I'm going to add a second exposure, and this second exposure we're going to put at, say, 1200. And what that does is it gives me a second exposure. It's going to run consecutively. It's going to do a first exposure and a second exposure, and it's going to merge that data. So here it's color-coded. The first exposure is red. That's the points are created in red. And the second exposure is in pink. So these two now create a full profile, and that full profile now is something that can be used on the measurement screen to create tools. The only cost to doing that is that we're now dropped our speed by a factor of 2. So we went from 200 profiles per second to 105 profiles per second. So we've pretty much cut that in half. So if I have a process where I don't need a great deal of speed, certainly using multi-exposure can add a much more robust profile to the measurement. Now, if I go back to a single exposure, and let's say I put this block of wood back in here, one note about this, these are very low numbers. So 800 microseconds, if I drop this down to say 400, which is what I had before, This exposure level is very low, and one of the things I want to point out is that because it's so low, 400 microseconds, it's very, very immune to ambient light. So I'm sitting here, there's some bright lights in the room. Basically, we don't have to worry about lighting causing problems. Typically with 2D vision, you can have issues with ambient light affecting your measurements. I'm going to use my phone here, and I have a strobe light, and I can just sort of flash this target with some fairly intense light, and you can see that there's no perturbation to the profile. You install this in some sort of a plant environment with some lighting, you really don't have to worry about shrouding it or keeping light away. We even have some sensors that work outdoors in the sunlight without any problems. So it's a part of the laser measurement capability where ambient light really isn't something you have to worry about too much. We've kind of learned how to optimize our exposure, and we've shown a couple of tools. I kind of want to get back into that profile tool set because we didn't really look at all of those tools. There's a lot of different profile tools, and we add new ones with new firmware releases quite often. So I want to show a few things. I mean, yeah, we showed a width and a height measurement, but there are much more, I guess, sophisticated tools. I could put this block of wood in here, for instance, and I could measure things like angle. So there's an intersect tool that I could add. And in this case, let's say I just put this feature box on top of the target here, and we're measuring angle. So here's a -10, -12, -15 degrees, +10, +12, +15, +20 degrees. Not only can I measure an angle from this relative to my 0 angle, I can also measure 2 angles together, and I can also get intersect points with this tool. That's why it's called the intersect tool. I can get intersect points in space based on 2 line projections. Another tool could be a circle fit tool. So if I use this tube again that we had before, I could select the circle tool. I'll add that in there, and here it will take a region of interest and do a circle fit. So I don't really even need this entire object. I can actually select radius, and this does a circle fit and tells me the radius of the circle that it fits to. In this case, it's about 20 millimeter radius. We also can get the X and Z location of the center of that circle. So this tool is very good for looking at edge radius of objects that users might need to measure. And then there are some more sophisticated tools. We have a tool that was designed to measure grooves. Certain products like rubber extrusions and things like that have grooves. I'm going to use this target real quick to just show how a groove is measured. This tool is a little more sophisticated in the sense that there are open parameters that the user can adjust based on the type of grooves they want to see. In this case, we have an option for a V-shaped groove or a U-shaped groove. So I'm going to select a U-shape for this. And here's where I might want to do a little bit of filtering. We didn't really talk about filtering. I can go into the scan profile, and maybe I want to, you can see there's some gaps here based on occlusion. I can go in here and do some smoothing, some very light smoothing in X. This is a moving average window. Of course, I don't want to over smooth, but let's say I want to smooth to say 1/4 millimeter. I can do that, and I can also do a bit of gap filling. Gap filling just allows me to fill in gaps of certain sizes so that I don't have any breaks in here based on occlusion. So this profile looks much better for us to do some groove measurements after I've done some filtering. And when I get into this tool, I'm going to take this feature box and drag it over the entire object. And I get to decide what a groove is. So I can actually define its minimum depth, its maximum width. Right now it's not quite finding the groove I want because I haven't really set it up to do so. So let's say min width millimeter, max width, we'll say 3. And what you'll see is that it is currently measuring, let's see, we'll put that to 4. And we want to get the, let's say we want to get the width of the groove. And it's finding among this large field of view, and real quickly I'm just going to, you'll see that my CPU, this tool is using a lot more power. So I'm just going to drop my speed down a bit so that my CPU is not maxed out. We probably don't need to measure this groove 200 times a second. We're going to set it up for 50 hertz, which should be plenty. And if I go in here, what we're doing here is it's finding, from this entire field of view, it's finding the groove that has the largest depth. But what I could do is index from one side or the other. So I've dragged it over this object. We've got what I think is about 12 grooves in there. And right now it's at index number 0, meaning it's measuring that first groove. And if I wanted to measure the second groove, I could just put in index number 1, which would be the next one, and it moves over to measure that groove. And likewise, I could just keep going and measure whichever groove I want. So in this case, if I wanted to measure all the grooves, I would just set up multiple tools, give them different index numbers, and I could measure every groove in this field of view. And this is what we do for various objects like rubber extrusions and metal extrusions like that, where groove measurements are required. Another very sophisticated tool is the gap and flush tool. So this is in profile panel. I'll add this, and I'm going to use this. It's really an electrical switch plate, but it's got two surfaces here that have a gap, and I can actually change the flushness. Most gap and flush measurements that we do are typically on auto body panels, doors that fit, cars with doors and hoods, deck lids, but also you can have gap and flush requirements to measure things with like consumer electronics or appliances. So I'm going to take this profile and I'm going to add this tool. So this gives me two feature boxes, a left side and a right side. I'll drag this left side over here. I'll create a right side one. And we're going to measure the gap. Now, measuring a gap is actually quite complicated because if you have surfaces where you have a radius on each side, the question is, where do you measure the gap? Do you measure at the top, somewhere down into the surface? And based on what we know from the automotive industry, there's specific open parameters you need to be able to tweak your measurement to get the right gap based on how you like to measure them. So if I open up this left panel, we're going to take this left side and we can determine various parameters to measure this gap. In this case, I want to put a radius of curvature on the edge, and there are capabilities to find this material. And these surface width, surface offsets, these are actually what define what the left side is. And you'll see I have a small circular where I change the radius to about 1/2 millimeter. And I'm going to go to the right side and do the same thing. So we're going to put the parameters, say 3 millimeter surface width with a 2 millimeter offset and a 1/2 millimeter nominal radius. So now this tool, as you see, we are measuring tangent to tangent from the various radius of curvatures on the edge. And this is typically how you would set up a gap tool. And we're measuring right now a 1.6 millimeter gap. And if I just kind of slide these a little bit wider, now it's at 1.9. And so it accurately measures that gap from tangent to tangent. What we can also measure at the same time is the flushness. So the flushness is really the height differences of the two surfaces. How flush are they? And with this switch plate, I can raise one or lower one. So simultaneously with the gap measurement, I can also measure the flushness. So those are some of the more sophisticated tools. There are other tools. We can measure things like strips. We can do line fits and standard deviations and some roughness measurements as well. But these tool sets really keep evolving, and these are really kind of the basics for how we measure on profiles. Okay, so I've set up various tools, including this gap and flush tool and the groove tool. And regardless of how I set this up, I'm setting exposure, maybe there's some filtering in there, and I'm creating various tools, configuring my outputs. And when I'm all done with that and I'm completed with my application development, I can then save that as a job file. It's very easy to do. Just go in here and select a name. I'll just call this job A and save it. And it saves the job on board the sensor. And so I can go into the manage screen and see that job. If I go here to select jobs, you'll see job A, it's loaded. It's the default job at this point. And these are really just all the settings for that particular job. So some users may have the sensor mounted above a conveyor, measuring certain product, create their tools, and then they may want to do a changeover where they're going to measure a different product, and that's where you would have a second job. You can save as many job files as you want on board the sensor, hundreds, if not thousands. You can also download those jobs to your computer and upload those into other sensors. So if you wanted to take that job and maybe duplicate your line, you could take your settings and just upload it into a new sensor. So the job settings or the job files show up here, and they can be loaded. New jobs can be loaded through this interface or from a PLC or from a computer using our SDK.